This video is sponsored by Reyax Technology. More on them later on the video. Hey, hello guys, this is Shubhakroto and welcome back to my channel circuiTician. Many of you heard about the term access control system. Access control system means to control the access or entry of a person into a specific place. A general purpose access control system allows an authorized person to enter into a premises and store the data with timestamp, and it also restricts any unauthorized activity or any unauthorized entry. But in most of the cases, the data of every action is stored into local database like any EEPROM chip or SD card, etc. So for that, accessing the data is very difficult because to access the data you have to go to the place where the system is installed. So to solve this problem, today we will make a IoT-based access control system. So don't skip the video, watch till the end. Let's get started. There are many types of access control system available in the market depending upon the method of access, like RFID based access control system, NFC based access control system, and in the biometric section there is fingerprint based, eye retina scanning, face detection based access control system. But today we will make RFID based access control system, and in which IoT is included obviously. And to make this project we will use RYRR10S RFID NFC module, and this module is sponsored by Reyax Technologies. Reyax Technologies is a leading total solution provider of wireless modules. You can find various types of wireless communication modules like LoRa, Zigbee, GPS, etc. on their website. You can find the link in the description below. This RYRR10S module is based on ST Microelectronics STCR95HF NFC and RFID engine chipset. It supports IEC 18092, 15693, 14443A and 3B standard NFC protocol. The RFID antenna is embedded in the PCB. The module has two types of communication protocol, UART and SPI. But the module we got from Reyax that have only the pinouts for UART communication. The RFID or NFC frequency is 13.56 MHz. We also got a 13.56 MHz RFID card with this module. For communicating with this module, we will use ESP32 as a microcontroller. And for storing the data into the cloud, we will use InfluxDB. For recording the data in cloud, we are using InfluxDB, which have a free plan and have various formats to show the data like in table format, graph format and many more. Now for testing the RFID module, we will connect this to ESP32 according to the circuit diagram. I have also attached a green and red LED for access granted and access denied indication.
Hey, hello everyone, this is Shubhakroto and I am going to explain the coding part of this tutorial. So before going into the coding, I am going to explain the algorithm behind it, the IoT based RFID access control system. So at first you have to set up, in the step 1 you have to set up the RFID reader for any new card detection. In step 2, set up the cloud database, which is in our case influx data, for the RFID card entry details. You have to set up the API token and organization ID for your influx data cloud database. And step 3, check for any new card. You have to continuously check if there is any card. In step 4, if new card is detected, then check its card number. If new card is detected, then check its card number. And in step 5, if card number is matched, then grant access and log the card details with timestamp. So if there is any new card, you have to check if that card number has access or not. If that card number has access, then grant access and log the card details with timestamp in the cloud database. Or else, if that card does not have access, you have to return to step 3, which is check for any new card. This is the basic algorithm behind this tutorial, IoT-based RFID access control system. Now, coming to the actual coding. As you have seen in the step 1, we have to set up the RFID reader for card detection. So this is the step 1. We are setting up the RFID card for card detection. As you know, we are communicating with the RFID card using UART communication, and the baud rate must be this 57600. And after that, after setting the baud rate, you are sending some command to setting up the RFID card. At first we are sending the echo command, then information command, then we are selecting the protocol, then we are synchronizing the outputs of the RFID card reader, and then we are setting the modulation and gain. Now these commands are byte commands. As you can see, these are the commands. This is the protocol select command. This is the timer synchronization command, and this command is for setting the modulation and gain of the RFID reader. This is the echo command. These all are written before, and we are just bursting this command using our hardware serial 2. We are using the hardware serial 2 of ESP32 and sending the commands one by one after 100 millisecond delay. And after sending the command, we are checking the response. This check response function, here it is. This is the check response function. So this is not in the void setup, but this RFID underscore start function will be called from void setup, from the main function. As you can see here, this is the void setup of the main function, and RFID start is being called here. After calling this function, the RFID will be set for any card detection. After setting up the RFID card reader, now we have to set up the InfluxDB database. For that, we have to log into the Influx data cloud database. So as you can see here, login and log into InfluxDB Cloud 2.0. You can use your Google account to sign up with the InfluxDB Cloud database. Now I am logged in. Let's set up the InfluxDB database for our ESP32. Actually, it is pretty simple. If you look at the left side, you can see here sources, and in sources you can see here the Arduino client library Arduino. So here are all the instructions that you may require for setting up the ESP32 for InfluxDB. At first, you have to include this InfluxDB library from library manager. I have already included it. It is pretty basic stuff. And after that, this is the code for initialize the client. And so for initialize the client, you have to first connect to the Wi-Fi and replace this using your Wi-Fi SSID and password. After that, you will require the InfluxDB URL. So my InfluxDB database is hosted in Southeast region. So this is Southeast. And then InfluxDB token. So the token, you will get the token from here, API tokens. This is the token. So if you generate token from here, make sure you copy this API token now because it will not show up again. So as you can see, make sure to copy the custom API token now. You won't be able to see it again. So make sure you copy it now and save it in your code or other places like any notepad. So make sure you copy it properly. So I am not going to use this API token I have just created. I am using this RFID log API token. Which is this one. And after that, you have to define the InfluxDB organization ID. And where can you find it? This is the organization ID. Copy it and paste it here. And this is the bucket name where you are going to save your RFID data. The bucket name is RFID log. For me, you can name it anything. And then you have to set the time zone. As I live in Kolkata, this is IST-530. This is the pretty much everything to set up the influx data database. Now after setting up the URL, organization ID, bucket ID for the InfluxDB database, you can initialize the InfluxDB client by using this function InfluxDB client, and you have to pass all the arguments we have just set earlier. Now we have to set a data point for our RFID card reader. Point sensor, we have named it RFID log. So under this RFID log, all the relevant information of our RFID card and when and who are accessing this RFID access control system will be stored. And this is our sensor tags, device ID, device name and device ID, sensor tags. And here we are checking the server connection. Server means in our case the InfluxDB database. So we are checking the connection with the InfluxDB database if it is intact or not. And after that we are coming to the void loop part, where we are sending the command for detecting if there is any new RFID card. Detect command, as you can see. And after sending that detect command, we are checking the response and getting this. Now coming to the loop part. At first we are sending the detect command to detect if there is any new card and recording that response in the string NCD. And if there is any card, then the string value should be this 128540400. This means there is a new card. Now if there is a new card, then we want to check the card number. To check the card number, we have to send this ATC command, which is stored here. ATC command, this byte command. After sending this, we will get the a string with the including the card number. So the card number will be index number 4 to 17 within this string. So that's why we are getting this substring, and the card number should be this. I have hard coded the card number for this tutorial. So if this ID substring matches with this card ID, then you will access the system. And this is the function where I am writing that a card has accessed the system. As you can see here, these are the card details in the InfluxDB database. And the card number is recorded here, and the time also is recorded here. So I'm not going deep into the InfluxDB database. If you want separate video on the InfluxDB database and how to properly set it up for any IoT project, then let me know in the comment section. So this write influx function, here it is. This is the function which is doing that, doing these logs. Client.writePoint. It is writing all the data from the card and timestamp to the InfluxDB database. And whenever the card ID matched, it is being called. And when the write influx is called, then the green LED will turn on. It means the access is granted. And if the card ID does not match, then it will print access denied, and the red LED will turn on. So this is the basic code for IoT-based RFID access control system. I hope you have understood the basic algorithm behind it. If you have any query or any doubt regarding this code, let me know in the comments. Now let's jump into the demo part.
If you guys love this video, then make sure you hit the like button and share this video with your friends or in any technical community. And if you are not subscribed to my channel, then subscribe to my channel because it's free. And if you have any query regarding to this video, then comment down below, and you can purchase this RFID module by going into the link which is in the description, and you can help me by buying me a coffee. And the most important thing, be free.